So the item is A, B, C, D, E, and the value, or the weight first. The weight is 125432, and then it has a value. And the value is 108256. Right? So now the problem here is that we have a limit. The limit is a bag that can carry no more than 15. So what we want to do is to maximize the value of the items that we are getting, but we cannot go over the limit of 15 kg. Now here I think there is also a restriction that you can only take a copy of any one item. So that means that there is only one of A, one of B, one of C, one of D, one of E. So you cannot take 2 copies of them. Now to do a brute force, it means that you will have to consider all the possibilities, right? So brute force is all the possibilities. So what kind of possibilities are there? So we have to generate all the possibilities and then test whether or not it breaches the limit of 15 kg, and at the same time what is going to be the value that is going to result in, so that we can take the maximum. Now in this case, for example, for every item, effectively we have 2 choices, right? So we can either take the item or not, right? So let's say I can take the item A or not, so I can consider it to be a 1 or a 0. So if it is all 1s, then essentially the total weight, so we can compute what is going to be the total weight. As well as the total value. So in this case, you breach the limit, 26, although the total value is 31, so this is not a valid answer. Then you might try to take some items off. Then at some point, you might actually reduce it beyond a certain value, right? So then for every item here, you have a choice, a binary choice, whether to take it or not. So then that will allow you to generate a brute force by just having these 2 options, taken or not, and so on. Now these options over the 5 items would mean that we have 2 times 2 times 2 times 2 times 2. So which means that there are going to be 2 to the power of 5, 32 possibilities. So 32 possibilities that we are going to examine one by one in order for us to get the final answer. So in the general case, all this is going to be, so if you take the product of them, right? So 32, which is the number of possibilities. So this one effectively is 2 to the power of n. So where n is the number of items that you have in the selection. So that is the brute force case. So you realize here the kind of brute force that you have determines the kind of solution, or the kind of the kind of problems you have will determine the kind of brute force solutions you need. This is essentially a combinatorial selection problem. This is when you need to choose some number of items from a selection. Now, in this case, it will be 2 to the power of n, which is exponential. Now, in the case of the Chapman-Salzman problem, the choice is not just combination, the choice essentially is permutation. So if it is permutation, then you need to care about the sequence. Whereas in this case, the permutation doesn't matter, because whichever sequence you put the item into the bag, the value will still be the same, right? Now, this is the case for brute force. Now, but we can also solve this problem using greedy algorithm. And for greedy algorithm, we are going to look at how to be greedy in terms of the criteria that we have. Now, in the previous cases that we have seen, the greed comes in terms of one objective function, right, which is the value. In this case, we actually have two objectives. One is it's a satisficing objective, which means that we just want to make sure it's not going to be over 15. The other one is a maximizing objective, where we want to make sure that the total value, is going to be as big as possible. So one possible way to do this is to look at this in terms of different kinds of greedy. So we can be greedy, for example, based on the weight. So if we are going to be greedy based on the weight, it means that we are going to take the smallest weight item first. To make it simple here. Alright, so let's sort it based on the weight. Now, if we are going to take the smallest weight first, then the first item that we are going to take is going to be E. The weight is 2, the value is 6. So now we still have space in the bag, because the bag is 15 kg. So we're going to take the next item here that has the next smallest weight. So it will be D. And this will bring our total weight to be 2 plus 3, which is 5. Right? And the total value to be 11, which is 6 plus 5. Then total weight is 5, which means that we still have space, because our bag is 15. So then we take the next one in again, which is C. So when I put the C in, so to be more accurate, this is with the C in. So in this case, C is going to add 4, so that is 9. And it's going to add 2, that is 13. Now we still have space in the bag, so we can then add B in. So B is going to add 5 to the weight, so that's 14. Then it's going to add 8 to the value, and that is 21. Now at this point of time, we are nearing the limit of 15, and we can't possibly add A into the bag because this will be over the limit. So this is one possible solution. Now we can also try to be greedy in different ways. So we can also be greedy based on the value. If we are greedy based on the value, then what we are going to be looking at is the one that maximizes the value first. So in this case now we are sorting it based on the value, in which case we are going to take A first, and A will already have a 12, and the value will be 10. Now at this point of time, we can't take a B, because B will be over the limit. Then we can just keep going down the list. And the next one after that is going to be E. So then we can take both A and E. In this case, the total weight is 14, and the total value is going to be 16. So here is 21, B, C, D, E. This one is A and E, will give us 16. So depending on what is a greedy criterion, we are going to get different answers. Now, because we have two objectives, we can also try to combine it in some way so as to achieve a balance between the two. So one way to do that is to be calculative, and we're going to ask, if I'm going to add something, how much value am I going to get for every unit of weight that I put into the bag? So in this case, so we're going to compute a ratio, right? So now this is the ratio, and what this ratio does is to look at what is the value per unit of kg. Now, if you're going to be greedy based on this, we can try to sort it again. And then we see that there's going to be E first, because E is going to give me the highest value per unit of weight. And in this case, it will give me 2, and the value is 3. So it allows me to take in the next one, which is D. So it's going to be 5, the value is going to be 8. Then it will give me B. Sorry? The value of E is, oh yeah, right, that's right, 6. So ED then will be 11, right? Okay. Alright, so EDB, the next one is B, so it will take me to 10. And the value will be plus 8, so 19. So in this case, I cannot take A, because A would be over the limit, but I can take on C, which will give me EDBC, 1421. Now it just so happens that the answer I'm getting is the same as the greedy by weight. But in the general cases, generally, the last one will do better because we are considering both cases, like per unit of weight. Okay? Now, but again, it's still a greedy solution. So which means that in this case, for the weight of 15, you probably already get something that is the optimal. But for some other weight limit, your greedy may actually fail to find the optimal solution. So if you pay attention to, let's say, the last greedy, right? Now, is there any particular limit where they might actually do badly? That means that they will discover a solution that is not the optimal. Right, so let's see. So let's say if we set the limit, let's say instead of 15, we set it to 7. So what is the greedy solution? The greedy solution will take in E, and then it will take in D, which is the total weight of 5. But it can't take on B or A or C anymore, right? So in that case, the solution will be ED. We have a weight of 5, and the value will be 11. But there will be some other combination that is more optimal than this. So for example, if we had skipped the D, because this one is and we go on to the next highest one, which is B. So E plus B will still be 7, right? And the total value in that case would be 6 plus 8, which is 14. Now in this case, the greedy will discover a suboptimal answer because the optimal will actually be higher. So it means that depending on the limit of the bag, sometimes the greedy algorithm may actually fail to discover the optimal solution. Right? Any clarification about the heuristics? So some of the common mistakes that sometimes students make is that in some cases when you are being greedy, at some point one option doesn't work and they will stop there. But if one option, for example, A, E, and then you put D, let's say you cannot put B in, it doesn't mean that you stop there. You will still go through the rest to see whether or not there is something else that you can still put in. I think this is one of the common mistakes, thinking that you stop as soon as you fail, but that may not always be the case. Alright, so if